effort here. Okay.
Yeah, Dr. Gijs, the recording is
there we go. All right. So welcome everybody to our, what is it? It's the third session, but there are a third of three on Python for robotics. And we've got Tanya with us again. And Tanya, as always, I'm sure you're going to challenge us again. So thank you for joining us from Windhoek. We're going to have you in our midst soon. So that's going to be great. Casper, you want to read the house rules? And then we'll hand over to Tanya. Thank you.
Thanks so much, Dr. Gijs. Welcome everybody to today's session. We only have a few small house rules for today. We'd like to ask everybody to please mute your cameras to save data and bandwidth. Also to mute your microphones to keep all the background noise to a minimum. If anybody has a question at any point in time, please feel free to raise your hand. Then please enjoy the session. Over to you, Tanya.
Okay, well, welcome again, everybody. Today is our session on Spike Prime and how to program the Spike Prime in Python. And I thought in order not to bore those folks who were present on the EV3 session, I'll make my examples slightly different and also kind of like don't do the PowerPoint again. So we're going to program in Spike Prime. I have the Spike Prime app here open on my screen. I want the Spike Prime. And remember, the easiest way if you want to do something new is just kind of like press new project and it gives you choices. And we want the Python choice and we say create. And then it creates a new project for us. And then Eric was so kind to tell me that this is where I make it bigger. So now, well, everything gets a little bigger. In terms of the fonts, we have kind of like 3 lines on the top where we're importing from a library called Spike, all kind of like stuff as in our robot. And I hope you guys can still see me because that window disappeared. So the hub is the yellow brick, or just kind of like the prime hub. The light matrix is the light matrix on it. Buttons with like a left and right button next to the center button. We have like the status light. That's around the button. The force sensor, I actually have it connected here. Here's my force sensor. I keep calling it the touch sensor, but this one actually measures how strong you push it. I don't have a motion sensor connected. The speakers, the color sensor, the distance sensor, and so forth. We'll look into some of those today. And then we have a couple of control items, Spike control. Kind of like a wait for seconds, that's helpful. A wait until, that I don't like because it's very un-Python, and a timer. And then we can also import some math, or if we don't want to do any math functionality. So that one would import like cosine, sines, pi, and so forth. But we can comment that out, and commenting out in Python is always with the hashtag. And then we need to initialize the hub or the brick. And we can call it whatever on the left. That's our object. I have one of those, and that's the prime hub. And then the hub light matrix can show the image happy. At the moment, mine still shows the heart. And I could run that program. And let's see, all it should do is show the heart. Shows happy. Yeah, there's happy. And then it keeps the happy face on. So my robot is happy. Now that my robot is happy, I hope you all are also happy, and we can look at a couple more examples. So let me open some of the examples that I have created beforehand. And yeah, how do we go about learning Python? So our knowledge base is this window here on the right, and we can come like make everything, make it disappear. If it's in our way, we can make it show up again. And I haven't found it online yet. Correct me if I'm wrong. Would be nice to have this in a separate browser window, but that's kind of like how you learn to program in Python. You can start with the getting started and go through all the different modules. or you can just kind of like search whatever you think you want to search. Okay, this very first program, I call it example 1, is an example where all I'm going to use is the light matrix, and I just want to get you kind of like set up for sequential programming. So kind of like, how does a Python program work? And here we have another window that I can make disappear. Then we see all of my program. So the program is executed in sequential programming from the top all the way down to the bottom, line after line. When one line is done, then the next line will be executed. So since on this example, all I need is the prime hub. And yep, I hope it will work. I might need the light matrix, and the wait for seconds, I've deleted most of the rest, and we'll see if I've deleted too much. So I initialize my hub. Again, like I called it differently here. Sometimes I call it robot, sometimes I call it my hub. On the right-hand side, it needs to have the name of the class. It's of class prime hub, so I need to write it exactly the way I want. And the left, that's just kind of like the object. So I have one object here. Okay, let's see if it runs. It makes noise. It shows something, so it seems to run. Okay, let's just look at it. It says hello. And it should say goodbye. There we go. And that was it. So let's see what exactly it did. Well, everything in green with a hashtag at the beginning of the line is a comment. That's just something just for me or for the user who writes the program. And so we initialized our hub, we write our program, and well, so that's the yellow brick or hub, my hub. And then it has, with that dot notation, it has a method or an attribute, actually an attribute that's called light matrix. So we see the light matrix, and on that light matrix, I can show images. And what images can I show? Well, I can learn about it by going here in the knowledge base to light matrix. And then I can look at show image. And here are a bunch of images you can pick from. I picked the ghost, and it looks like I picked the ghost twice. So let's take the second one and make it something else. We'll just pick clock 1. I have no idea what clock 1 looks like. So here we need to copy it exactly the way it's written in the knowledge base. So now I have clock 1. So when I show something on the light matrix with show image, in addition to which image I want to pick, I can also pick the brightness. If I don't pick anything for the brightness, it makes it brightness 100. So here I didn't pick for the ghost, I didn't pick anything. For the clock, I pick a brightness of 10. In addition to showing images, I can also write with the light matrix. That actually allows me to do so. So before I write something, I switch it off. In between, I always wait for 2 seconds such that it's just kind of like visible on what's going on. And then I've decided, let's write the word hello onto it. So again, how do I know I can write onto the light matrix? Here we have the different actions we can perform. We can also, you see, like here, I can switch the light matrix off. Switch it off, it doesn't need any input parameters, so empty brackets. To write something onto it, says here you need to use it right, and then you need to put some text. And text is of type string. And strings are in single quotes or double quotes in Python. So everything that shows up here in red, it's a string. And yeah, so we write the word hello. Since the word hello doesn't fit onto it, what's going to happen, or what you saw happening, is that the letters walk through the light matrix, and yeah, and then we also say goodbye and we switch everything off. So if I run it one more time, the number 0 for its program 0, here's my ghost. And I guess with light brightness 10, we don't see anything, so we didn't see the clock. There's hello. And there's goodbye. So maybe I should make my brightness bigger than 10. I didn't see it. I'm sure you didn't see it. But that's basically the idea on this program. Execute command after command. Yeah, one after the other. When the program is run, most of these commands, actually all of these commands, are specific to the Spike flavor of Python, because it's all imported from, like, we use the hub and we use the light matrix and the wait for seconds. So all those are specified commands that don't exist in primitive Python, but that somebody has created for us. Okay, but it makes the go and program your first program really easy. Okay, so that was our easy start. Let's look at another program. Let me open another one. Next one. Okay, like last week, I really don't want to do anything with motion today. I think we can spend a week on motion and how motion really works and why the robot knows how far to go and so forth. So we're not doing anything on motion here. But what we're going to do today is in just kind of like different concepts of programming. So this one is called if-else with force sensor. So that one actually uses this dangling force sensor here. So let me put my robot back down. And well, if I want to use the force sensor, I need to tell the program that I have a force sensor. So here we import what we're needing. And I'm not sure, I don't think I actually need this one, but I'll just keep it. So we import the modules. Oh, up here, I've just commented out like what it always imports, such that I get some idea, some reminder of what my choices are. So we're importing the prime hub, we're importing the light matrix, we're also importing the force sensor, because we're going to need it. Okay, so now it knows that those classes exist. Now we still need to initialize what we're going to use. I use my hub. So this time it's called my hub. It's of class prime hub. So that's my object. That's my yellow brick. Then I use the light matrix. So I call it light matrix, and I initialized it from the class light matrix. Doesn't need any input parameters. And I call, because I'm kind of like used to it, my force sensor touch sensor. And it's of class force sensor. And it is connected. I need to say where it is connected to. So it is connected to port A, and I need to put that letter A into single quotes, so it needs to be a string. Okay, so since we're using the force sensor, here's what we get to what we need to know about the force sensor. So kind of like here, initialize the force sensor. They connected it to port E. I connected it to port A. Doesn't matter. What can it do? It can measure. It can make measurements. It can kind of like, it has a method called isPressed, and that one returns either true or false based on whether it is pressed or it is not pressed. And you do have a little example on the bottom on how it works. This is actually kind of like a good example, and I'll show you another example kind of like along the same lines of how it works. Okay, so now we can kind of like create our program. First thing I do is I make my speaker beep. From the hub, there's a speaker. So my hub has a speaker that can beep. I'll just use the default beep. And it's really hard to hear, so you won't hear it, but it's for me such that I have 4 seconds to decide if I want to press the touch sensor or not. And then we're going to do something that's called selection, or it's an if-else statement. So if the touch sensor is pressed, then it'll show, like my light matrix will show a happy face. It shows the image happy. And then it'll be done and switches the light matrix off. And we can make this a little shorter, maybe like just 3 seconds. And then otherwise, when it's not pressed, it'll show the image heart. and yeah, also be done. So the if-else statements work the following way. You need to have the word if, and then you need to have a condition. A condition, you need to have an expression that's either true or false. And we just looked up what touch sensor or like what is pressed does. It returns true or false, depending on whether I press it or not. So when it's pressed, then it returns a true, and we execute this line of code, show the happy face, and jump after we're done with that line directly to line 25. So we have a way of jumping over portions of code. Now, if my touch sensor is not pressed, it'll execute the else statement. And on the else statement, it'll show the heart. So I will play this program twice. The first, and I'll hold up my robot. The first time I'm not going to do anything, so I'm going to ignore that touch sensor or force sensor. Let's run it. And it's waiting for the 4 seconds here. Ah, there's the heart already. Okay, and it shows the heart. It waits for 3 seconds, and then it switched the light matrix off. So that was showing the heart because I was hiding the force sensor and not pressing it. And it's all dangling around here. I haven't built a really nice robot. I've actually borrowed a robot from our FLL team. Oops. So I guess I pressed it again. Let's see. So let's run it again. I just tend to run it just from here. And now I'm pressing the force sensor, and you see the happy face instead of the heart. And it's not going to show the heart because after it shows the happy face, it jumps to statement line 25, wait for 3 seconds, or wait 4 seconds, and I give it a 3, and then it switched the light matrix off. So an if-else statement is something that's called selection. It allows us to jump over code. I can modify it a little bit just to confuse you. I can change my condition, my true false condition. So I've added like if touch sensor is pressed is equal to false. Now, if I want to check if something is equal to a value like true or false, then I need to use 2 equality signs, because with 1 equality sign, as I used it up here, I assign a value to a variable. So if you're checking if something is true or false, then you need 2 equality signs. So what have I changed now? So now this condition, it looks, is touch sensor pressed false, and then it checks is false equal to false, and the answer to that is true. So it'll show us the happy face when I'm not pressing the touch sensor, and it'll show us the heart when I'm pressing it. Let's see. So I said happy face if I don't do anything to my touch sensor. So I'll just let it hang down here that you can believe that I'm not doing anything to it. And I need to kind of like, okay, it's an upside down happy face. I should have held it this way, but you get an upside down happy face. Cool. So any expression that can be true or false, that's the block we're doing here. And then in the other case, and there's never any condition behind else, we're doing it here. We're executing this code. How do we know which lines are, which statements are inside the if statement? That's this, those are the lines that are shifted to the right. So on your keyboard, if you use tab, then everything inside the if statement needs to have 1 tab to the right. Everything inside the else also needs to have 1 tab to the right. And once we start all the way at the left again, that's when we're back to executing code sequentially. Okay, so this was an example for selection where we did an if and an else. And next thing we're going to do is, let me say, okay, no, open. You open a new code. Okay, next we're counting. We're going to use a loop. So Again, we're using our Spike Prime hub. We're initializing it. It's called My Hub here. First step, I write hello onto the light matrix, and now I want the robot to count. As in, it shows the numbers 1, 2, 3, 4, 5 on the screen. So what I could do is I could copy kind of like this statement 5 times. And unfortunately, the copy and paste doesn't really work. So Eric, sorry, I was over optimistic. At the moment, my copy and paste doesn't work at all. So, but I could copy, paste, and write the numbers 1, 2, 3, 4, 5 in it. On the moment, I want to count more than up to 5. That becomes tedious. But let me just count like, and I want to change this a little. So I put my numbers 1, 2, 3, 4, 5 into square brackets. So where I'm creating an array that has those 5 strings in there. And now at the moment, I don't need this. And the way a loop works, so a for loop helps us to execute a code several times. And the same way as with the if statement, everything that is kind of like shifted to the right is part of my for loop. So inside the for loop, we're going to write count into it. And count is not in single quotes, so we're actually going to write onto the light matrix the value of the variable count. And I'll tell you in a moment what that value is. Then we're going to wait for 2 seconds such that we actually see what was written. Then we're switching the light matrix off and we're going to wait for another second. And then we're going to go back to the top and repeat everything again. So the first time we're running through this code, the variable count gets the first element in these square brackets. So it gets the value 1. So when it says write count, it looks, well, variable count, what value do you have stored inside? And it'll use the variable 1 and the string 1, and it'll write the 1 onto the light matrix. Next time we're repeating this count, we'll get the second entry, that's the number 2. Then, the string 2, so it's not the number 2, it's the number 2 converted because of the single quotes there, and it shows up in red. It's the text 2. And then the third time it'll give me a 3 and then a 4 and then a 5. So let's see this in action. What did I learn? I need to hold it this way such that you don't see the numbers upside down. I run this code. It says hello, it writes hello. Not 1, 2, 3, 4, and 5. So if that's what I want to do, I can just kind of like, so have those 5 numbers. So inside these square brackets, the individual kind of like comma separated text portions are the ones that the variable count gets as we go through the loop, and it'll display it here. Now, if I want to count, well, what I can go like my kids learn to count as in 1, 2, skip a few, 99, 100. So if we want to do 1, 2, skip a few, 99, 100, we can go 1, 2, or skipping a few, 99, 100. And now it'll skip a few. So now we'll go and it says hello again. 1, switch off, 2, 99. There comes 100, and there's 100. So we can also, like, it doesn't have to be all numbers or all any text. It'll go through the loop. The variable count holds track of how often have I done the loop. The first time it has this value, this string. The second time it has this string. The third time it has this string. The fourth time it has this string. And the notation or like the syntax is you use the word for, you have a variable name, and then in a list or an array, and it'll go through all those values. Alternatively, if you really wanted to count like to 10, we can also kind of like go and say for count in, and I can define a range. So I can say, let's start at 1, let's stop at 11, and let's go and only count the odd values. So go of 2. Start at 1, actually stop at before 11, but it goes in steps of 2. But now my count variable gets numbers. So I cannot write integers. So I need to convert it from an integer, from a number to a text. And now we should see the robot of like, let's get rid of the hello. We've seen the hello so many times. So let's put just count program 0. Let's see. Error message. We get an error message. Invalid syntax, it tells me. It tells me invalid syntax in line 13. And I didn't show anything. But invalid syntax, what did I do wrong? I forgot to put a colon here. I always forget to put colons because I mostly program in another language that doesn't need colons. But now it should work. Now you saw like how we deal with error messages. 1, 3, 5, 7, 9. We're not going to see 11, despite me saying 11, seeing here like go up to 11, because the stop value in Python is never included. So the syntax of range here is start value, stop value, increment. Start value is included, but it stops before it reaches the stop value. So that was like an easy loop. And we've seen loops. So we've seen selection. We've seen loops. We're now going to see a different type of loop. This is a for loop because there's the word for, and for loops really I recommend that you use them when you know how often you're going to repeat a block of code, a certain number of statements. If you have no idea of how often you want to do something, then you would need to use a while loop. And a while loop is kind of like while some condition is true, keep doing this. And a while loop is like your first step into, let me build an infinite loop, like a program that never stops. Okay. Let's open my while loop program. And let's have a look at what my while loop program does. Let's move the console away. Let's make this a little bigger again. Okay, so I've decided to use a little bit of sensor input. And you see my light sensor is already lit up. So what do I have in this program? Let's go start on the top. So we're importing the color sensor and the prime hub. So apparently I'm going to use the color sensor and the prime hub. I call it's my hub, which is of class, the object that is of class prime hub. I'm using the color sensor, so I'm using the class color sensor, which needs to know, same way as the force sensor, what port it is connected to. And since port A is for my force sensor, I picked port B was still available for my color sensor. So now the program knows that an object that I called light sensor of class color sensor is connected to port B. And what I want to do is I want to take you over to a mat. And that mat has kind of like black and white. And I want to kind of like create, well, I want to measure the light intensity. So I want to kind of like, I have a variable here, intensity. that gets the value of light sensor, the object, which has a method that is called get reflected light. So let's have a look here. So color sensor. These are kind of like we can get the color. It's kind of like measuring. We can get ambient light. I want to get the reflected light. And that one returns values between 0 and 100. And what I want to know, and that's kind of like why it says write down values you measured down here. I want to know what it returns when I have it point to a space that's black. And I also want to know what it measures when I point it to some space that's white. And I wanted to measure again and again and again. So here is how I set up my loop. It starts with the word while. And now here's that condition that needs to be true. And the condition that needs to be true is while I'm not pressing the left, which one is left? Yeah, I guess, well, while I'm not pressing the left side of the left button, so while I'm not pressing any buttons, it keeps going. It measures the intensity, the reflected light intensity. It prints it on the screen, so we'll see it, the values show up here as a number. It goes back to the top, it measures, it prints, it measures, it prints, it measures, it prints. Okay, let's see that in action. Let me move you guys with me. I'm going to take you along here. Over to our gear mat. I need to do a little bit of preparation. I'll show you what I'm doing in a moment, at least I hope I do. Okay, let's move this down here. And I don't see what I should see. So but let's hope you see kind of like what we're doing. So I have the robot. See if I can get like what Caspar showed me back. Here's the bar. I'm presenting. Okay.
Yeah, it won't show the robot because it is seeing it as a background. So you will have to stop presenting.
So I need to stop presenting. I cannot do, I need to stop sharing or stop
sharing.
Oh, that sucks. Then you don't see what's on my screen. This thingy is kind of like too smart for me.
Otherwise,
okay, I can stop sharing. Let's see what we got now. Okay, so now here I am. Hello, here's my robot. And the whole idea is that the robot is going to look at different positions. Kind of like I'm going to point it. What I want to do is I'm going to point it onto various portions of the mat that are black. So we have black here. We also have black further here. And then I have black here. So I'm going to move the robot around to various positions. And on my program, once I run it, it'll show me the light intensity it measures. And then I want to do the same with like positions of white. So at the moment, the light sensor points to black. Let me run. It's not running. Okay, so I'm running it. It points at black. I'm showing you later, but it shows kind of like on my screen and the console a value of 44. So I have 1 point that's black and it measures in light intensity of 44. If I put my robot further away to the black here, that also seems to be a 44. I have another, here's 46. If I go kind of like on the other direction, a little over there, it's 41, 42. So the point I want to make is like not all black positions give you the same value. Now I have a 45, but they all give me something in the 40s, somewhere between 41 and 46. And now I'm going to move the robot over to kind of like white positions. And for this white in the middle of the field, is there still a robot? There's still a robot. So kind of like there, it gives me a 96. It gives me another 96 somewhere here. It also gives me something in the 90s. So all my white areas seem to be giving me a uniform 96. And now I've measured enough points so I can stop my program by just kind of like pressing the left button. And the program has stopped. So I'm going to take you back, and then we can take a look at what we've seen. Hey, and we have somebody with the key here, so I don't need to leave at 5 to 5. I just need to make sure that the man with the key doesn't leave before me. Okay, taking you back to my desk and start sharing again. Here's my Lego window again. So we're back in our program. And these here on the bottom. So what we did is kind of like the program was running the entire time. It was measuring the intensity and printing it. And this print only worked because my robot is connected to the computer via the USB cord. And it printed a whole bunch of values here. Let's see what we all kind of like miss. Okay. So kind of like the program started and then I placed it somewhere. And remember, I put it on black before. So while it was on black and I didn't move it, it showed a whole bunch of 40s. So let me write down that black is roughly 45. And when I moved it later to white values, then it showed me like 96, 97, 94. So maybe an average like a 95. Okay, why do I want these values? I want these values such that if I ever kind of like want to stop at a black line, I know how I can set up my program kind of like to keep going on white and to stop when it reaches black. And I'll show you that kind of like on the next example. So this loop was moving and collecting data for the entire time that I did not press the left hub button, because it says while the button pressed is equal false, which means while it's not being pressed, while false equal false, and that is true. And it allowed us to take a whole bunch of kind of measurements until at some point I hit the left button and then this wasn't true anymore. And then it jumped to the print message goodbye, which we have on the bottom of the screen here. Okay, I do want you to I want to show you something here real quick. No, Siri, I don't need you. It's the big portion of the do not do it this way. But that's kind of like, unfortunately, how the Lego program, like all the examples here on loops, they're doing it that way. So it always kind of like, it's something I do not like to see. So it's kind of like the while true. A while true is kind of like you're setting up a forever loop, because true is always true. So it's kind of like you say, I want to do this loop forever. What am I doing inside the loop? Well, the same as here, as in I measure the light intensity and I print it on the screen. So just kind of like I set my loop up to to run forever. And how do I get out of my loop? I put an if statement inside my loop. If my hub left button is pressed, then please break out of the loop. So this works. It works just as well as this one, but it's just really bad programming style. Because instead of thinking your way through as in when do I want this loop to stop and put the correct condition here, it's just kind of like the lazy way. Hey, I'll just run forever. And now I have an if statement that gets me out of the loop. But if I know what my if statement is, that makes me stop. I can just kind of like set up my loop correctly with, I need the opposite of that if statement. So it's kind of like I want to stop if this is pressed, so then I want to break. So here it's kind of like, while it's not pressed, because the while loop keeps going as long as the condition is true. So while it's not pressed, keep going. So don't do this. I'm going to keep it in there kind of like, but it's bad programming style. It does work. Nothing wrong with that one. It does work, but it's just kind of like bad programming style. Okay, I think we have time for one more while loop that was going to use the black and white values that I've just measured. Because kind of like really depending on your light, depending on your light sensor, color sensor, depending on how far away it is from the surface, you get different values for like what's considered black and what's considered white. Now, if we have an example where we place our robot on white and we want it to move forward until the value turns black, then we need to know what does the light sensor, the color sensor pick up as reflected light in terms of values for white and black. We don't just want to guess. We need to have those values. And you can say like, I can read the values up here, and yes, you can read values up there. But we have them on, I think this one is called, this one is called, the example is called stop at road. So, what do I want to do in this example? I want to stop. Well, I had a road. So my road, I have, the scenario is I have a white mat and I have a black road or a black line. So you can also call it stop at line. Matrix, black line on my white surface. And I want to stop when the robot reaches that black line. And I assume that I place my robot onto some white surface. So I need to know what value is black and I need to know what value is white. So black and white here are variables and they get numbers assigned to them. Black as in, well, these are slightly, so I had like a 45 and a 95 roughly in my measurements. So I have a black and a white measurement and I can print whatever value I get from my reflected light as I start, before I start my robot. And now you do get a little bit of robot motion. Apart from I deleted all the imports, so this is not going to work. So we'll see if I get the copy and paste moving, but the syntax per se will work. So I create a threshold. It's kind of like, when do I want my robot to stop? I want it to stop at the black line. So I wanted to, while I'm collecting values, I wanted to stop really kind of like when the measure, like the line sensor get reflected light value, kind of like drops below what I consider white. So I define a threshold in the middle between these two values. And then while I get values from my reflected light that are greater than the threshold, my robot keeps moving. And it'll print the value from the light, get reflected light here. And then it keeps moving, moving, moving. And the moment, so we keep repeating these these lines of code. And then the moment we stop, that's when, the moment this turns false, we jump to the end and we need to tell it what to do next. And that's kind of like, hey, we want to stop. Okay, but unfortunately, there's a whole bunch of stuff here that I forgot to put in. So let me quickly see if this is the right program that I actually wanted to use. Seems to be the only one I have, and if the copy and paste would work a little better, you could just copy and paste in. Okay, let's see. So
Tanya?
yes,
Copy should work Control C. and to paste, you got to put the Shift key and then Control V. So it's the pasting needs the Shift key. You could try that.
Let's see. I need to go back to the project. The project I wanted. Let's just do it the other way. But I feel like we're running out of time and I'm disorganized right now. So I'm very sorry about that. We'll just open File, New Project, make it a new one. And what do we need? I need the Prime Hub. Well, we'll just keep everything in there. And I do need for this, since we're going to do some motion, I need the motor pair here because I want my robot to be of class motor pair. So again, this is something that is very specific to EV3s, so spike primes. And my motors are connected to port. This one is port D and port C. So I have port C and D to which my motors are connected. And this class motor pair is something, it's a class that somebody has written for us, assuming that we're building robots for which we have two motors that we want to move in parallel. Okay, and now I have a motor pair. I still need a light sensor. I think I'll just send everybody kind of like the program once it's ready at the end, because we're really going to, but I'm happy to keep going. But tell me questions. While I'm typing here, why don't you send me some questions?
If anybody has a question, please feel free to raise your hand, or you can put it in the chat area.
So my color sensor, that one was in port B.
Yes, Eric?
Tanya, I'm not going to distract you too much now, but it was very interesting. On your for loop counter example, the first one, what happens is if you comment out that time, wait for seconds.
Yes.
And you run it, it almost seems like nothing happens. But the thing that I've learned, and when I was using Scratch as well, is sometimes the computers calculate everything so quickly, you think nothing's happening. But actually, it's that the wait blocks that put the text on the light matrix, which helps.
Okay, so to bring it up, let's take a look here to go back to our light matrix. And yes,
so kind of like
if I comment out this wait for seconds here, let's just say we just wanted to, and we'll try this. Let's just say we just want to count up. And we want to count up, from 1 to, let's go from 1 to 10, so in steps of 1. And all we put inside is the write command. Then let's run it now without the wait for seconds.
And it'll look like nothing's happening or nothing worked.
It is, because all it did is kind of like I saw, well, we can, and let me comment out the goodbye, because the goodbye at the end takes forever. So all we do is kind of like we count and 0. And it seems like all we see is the number 10, as in the last number. But what I want to see is I want to see the 1, 2, 3 up to 10. And that's a really good comment, Eric. Thank you so much. It's kind of like if we don't put, so I don't need to switch it off every time, but I need to kind of like, it's so fast in kind of like going through these numbers here that it doesn't have time to write them. So if I wait for 2 seconds in between, now we should see our count up. This is just program 0, 1, 2, 3, and it keeps going. So if it doesn't do what you want it to do in loops, it helps to put kind of like give it a little time to wait, such that you make sure like you get a chance to actually see what's written on the screen before it writes the next one on the screen. That's a really good comment. So let's just keep it here. And I didn't get to my stop at the line, but I also opened the session with saying I'm not going to do any motion. So there we go. We didn't do any motion, but we've measured thresholds like the plus and minus, like the black and the white in a while loop. And then you would take the middle and kind of like if you start on white, you just can keep going while the number you're measuring is above that threshold in the middle. And the moment it's below, you've reached something dark. That's what I wanted to show, but we make another session on kind of like all the motion and motion with sensor input. I'll ask Miss Patricia on when, and then we'll keep it there. I thought I pressed stop presenting. So here I am again. The last thing I can do is I can take my EV3, my spike files, and I'm just going to sort out here the ones that are useful and the ones that are not useful. And I'll zip them again and I'll send them through the chat. And Caspar, Eric said last time it needed a password, and I don't know, is there any reason why it would need a password?
I haven't checked that document yet, so let me see quickly what happens when I download it.
Okay, and let me go to the chat, and I see there like messages and everything there. But I'll put it in and I'll wait a moment. Drop files here, yes, please. And now it's uploading, and then I still, let's see. There's something about like people in my organization can.
Oh, yeah, I know what's happening. So
anyone with the link is what I need to apply. Anyone with the link. So now if I share it.
Yeah, you're going to need to create a link that is shareable and that everybody has access to it. I know what's the problem. It's one of the newest problems, not a new problem, an old problem of we at UNISA also have this problem.
Maybe somebody can download it and try to unzip it, and then we know if it's working. Otherwise like in
you can
all
maybe send it to me and I will create it in a folder that you can just email it to me. I will be able to do it.
Yeah, we can do that. Also, like Patricia and I are working on getting stuff up on the UNISA MOOC, so we'll place it there for sure. If you want to know more about what's in there or have trouble with what's in there, Eric says it's working. So if it's working for him, it should be working for most of you. Just download it and eventually get to it when you want to play with it.
Okay. All right.
Then that's all I have for today. Any other questions? What do we have here with people? I have a number 1 there. Well, that was Eric raising his hand. Sorry, I didn't see that earlier.
Okay, so I see also Carmen has the same problem that I have. She can't download it. So what I want to ask is we will send it later on and it will be available on the MOOC portal.
Okay, can you download it, Caspar?
And not from my side.
You cannot.
Yeah, I can't download it from my side, unfortunately.
Okay, then yep, I'll send it to Miss Patricia because I have her email address, and then she can take care of distributing it. I can also send it into the WhatsApp group, the ISET WhatsApp group, if that's something you wanted me to do.
Okay, yeah, I will do it. If you just send it, I will upload it. Okay, but otherwise.
Sounds good.
Okay, but otherwise, thank you so much for everybody for joining us for the last 3 sessions. We hope you enjoyed it, and please enjoy the rest of your day. Thank you very much. Goodbye.